Today we are going to learn about object-oriented programming. In many literatures, in many books, they call it OOP. So it means object-oriented programming. We are going to learn three things. If the time is not enough, I will continue next week. But let's see which part that I can finish until today. We are going to learn about objects. Okay, so what is objects? And then we are going to look at the classes, attributes, and methods. So we will look what is class, what is attributes, what is method in the object. And in the second part, we will learn about object constructor. So we can improve the class with constructor. And at the third section, we will learn about encapsulation. So the encapsulation means we will have abstraction on the class. So this class is not our class swap value. Okay, so this is the class in Python. And at the end, we will look at the exercise about the O. Okay, let's go to the Google Colab. Okay, I already opened the Google Colab. Now, let's look at the problem. I think you already know last section, we learned about calculating the distance. Suppose we have the points. Now let's say the point, it is a kind of coordinate, coordinate of cities. Maybe the city number 1, it is located at the point x equals to 5 and y equals to 2. So the city number 1, this is city number 1. Okay. And then the city number 2, it is located at the x equals to 3 and the y equals to 5. Okay, so this is the city number 2. The city number 3, it is located at the x equals to 4 and y equals to 4. So this is the city number 3 and so on. Okay. So we have 6 points. Okay, 1, 2, 3, 4, 5, 6. And let's suppose the center. So we want to find the center. Let's suppose the center is 2.2. So this is the center. So write a program to calculate the distance between a point and the center. I have this point. So I need to calculate the distance between this point to the center. I have this center, I have this point. So I need to calculate the distance between this center and this point, and so on. Okay. Now we have, let's suppose we call it, this is the data. Okay. We have this data. What can you do in Python to make this data? If you learn the array section, okay, so you know that we can apply one-dimensional array. So what does it mean by one-dimensional array? We have only one square bracket, and then all will be the value. Okay. So let's suppose we have a variable city count. We will get the input from the user, how many points. Now let's say I have 6 points. Then you can have two kind of variables. First is x and the other is y. In this case, I'm going to loop. Okay, I'm going to loop from I equals to 0 until the city count. the city count is 6, for example, then I will do the loop from 0 until 5. Okay. And for I equals to 0, we will have the input point x, and the value will be append into the x coordinate. So I'm having one array. Let's suppose the input is x equals to 5. Then the x array in one dimension, it will be a value of 5. This is the input from the user, for example, and we put it into the index 0. We have another input y, and then okay, append to the y coordinate. So we have the y, and let's suppose we have 2. So we have another value in the index 0 for the variable y. We will do the loop. So x, we have, let's say, maybe 4. Okay. Now y, we have 3. We have, let's say, 2. Let's say this is 2. Okay, let's say this is 1. Let's say this is 3. Okay. Then we will have one-dimensional array of variable x, where we have one-dimensional array of variable y. So is it possible? Iron dapat kali? Yes, it is possible. But in this case, you need to understand, for this variable, I have a list. And for this variable, I have another list. And the index 0 means the city of index 0. The index 1 and index 1, it means the city at index 1. Index 2 is the city at index 2, and so on. So you need to understand this structure in order to make the points to answer this problem. Or we can have the alternative solution number 2. What is alternative solution number 2? We can apply two-dimensional array. Okay. So you already learned two-dimensional array yesterday. We learned, let's say I have an input for the point, let's say 6. So I have another array, or I have a list point, and this point start with empty list, and then I'm going to do the loop from the value 0 until the city count. So let's say the city count is 6, then it will be a value from 0 until 6 minus 1, then it will be until 5. Now I have another variable city, and it is an empty list. This empty list, I have an input from the user. So the input from the user is x, and then I will append it into the variable city. I have y, and then I will append it into the variable city. And then the point, it is an empty list. We will append the data of the city. Means we have a list. We have the point list. And we have the city, which is empty at the first time. After we input x, after we input y, we append, then we append the city. City is a list. So we have a list x and y. So suppose 5,2, for example. Then we have a list inside a list. We will do a loop, and then we start the city with the empty list, and then again input the x and y, and then append into the variable city. Then we have another point, for example, 3,3, for example. And then we have another loop to fill in with another point of the city, for example, 4.3, and so on. Okay. So this is a type of two-dimensional array. We know that this is the x and y of city index 0. This is the x and y city of index 1. This is the city of index 2, and so on. Now, we are going to learn about object-oriented. So how if we do the solution with object-oriented? OOP, object-oriented programming, is a programming paradigm where programs are organized around objects. Okay, we call it object-oriented. So we will check what is the object rather than functions and logic. So you learned already about function. You learned already about the array. But now we are going to go beyond this function and array. We are going to learn what is the object. We call it object. It is an entity that combines state and behavior. Whenever we have an object, we will have class. So a class serves as a blueprint or a template for creating the objects. In Python, okay, we have this kind of structure of the class. We have the class name at the top of the class diagram. We have attributes, okay, at the middle of the class diagram. And we have methods at the below part of the class diagram. So the class name, it means the name when you want to create a class in Python. The attribute means the member variables. Whenever you create a class, there will be some variables, so you need to define in this section. And whenever you have methods, you can declare in this section, methods. Now let's make one example. When we do with the OOP, yeah, we will create object. Each object created in a program is an instance of a class. Okay, maybe this is a little bit complicated for you. Okay. Instance. Okay. What does it mean by instance? When we learn about the point, we have x and y. Okay. One object, or we call it one instance. This is the instance. So one object, or this is one city, it is one instance. So let's suppose the city number 1, the coordinate is 5 and the y is 2. So we call this is one instance. Or sometimes we call it this is one object. I have another city at the index 2. And the city index 2, the coordinate is 3, 3. So this is another instance. So this is another instance. Or this is another object. Let's say I have 5 cities. If I have 5 cities, it means I have 5 objects. Or I can say that I have 5 instances. If I have 5 instances, so I can create this instance based on the class. Now let's see. I have the class. Okay, so we use the word class in Python and then define the name. In this example, I will use point. Then the class name, you can see in the class diagram, the name is point. Okay. Now, after I define the class point, you can put the colon. Next, I have a variable x. X start with 0 and y start with 0. So I can define this attribute here. So I have the variable x and I have variable y. Those two variables are integer. How do you know that those are integers? Because we start with 0. If the value is 0.0, so what is the data type? Okay, this is float. Okay, so you can understand that every numbers with comma or dot decimal, then it is float type. If x equal to 8, like this, then this is a string. Okay, so we can define the data type in the class diagram. So every people who look at the class diagram can understand, okay, this variable will be integer. This variable will be integer. Okay. Now let's make it blank for this moment. Okay, I will explain more about this section. We can say this section is the data members or fields, or sometimes we can also refer to the attributes. As I mentioned before, this is the attributes. So the class name, okay, we use the word class as I mentioned to you to define the class name, and let the class name is point. So the attributes means the place to define the variables. The attributes means to define the variable. In this case, we define x and y and let the initial value is 0. So you can define any numbers here. Now let's make it 0. After you have the class, now we need to create an object. Objects are created based on the class name. So let P is the object. So P is the object, or we call this is the object, or we call this is the instance. Okay, so let's make the first instance. The first instance is using the class point. Then I'm going to create this object P, and this is from the class point. Because the P is from the class point, now I can call the attributes using the object name. To call the attribute x, we use P dot x. And to call the attribute y, we use P dot y. So we can print P dot x and we can print P dot y. Okay, now let's look at the Google Colab. So I have the class point. The class point x equals to 0 and y equals to 0. Now I will print. Because x start with 0 and y start with 0, then when we call the value of x, it is 0. When we call the value of y, it is 0. Okay. Now, let's look at more problem. Let's make, we call it, this is the client code. Client code means we want to call the class, okay, or we want to create object. We want to create instances on the client side. That's why in some literatures, they mention this is the client code because we want to call the class. Now, suppose we want to change the attribute values. I have the x start with 0. I have the y start with 0. Now I have a new city and I do not want to use 0. So I want to replace x with 5 and y with 2. Now let's create another object, P1. Call the attributes using the object name and assign a value. So to assign a value, we can just use similar to the variable assignment. In this case, we have p1.x equals to 5 because I want to assign x equals to 5. And I want to assign, let's say, 2 into the variable y. And this is for the object p1. And then I will print p1.x. I will print p1.y. So I have, oh, this is 10. Okay, let's try. So I have p1, which is a new object, and I would like to assign the p1x equals to 5, and I want to assign p1y equals to 10. Now, what is the value of x? The value of x will be 5, and the value of y will be 10. Now, my question is, what is p dot x? P, p1. Then, if I want to print again p dot x, what is the result? 0. Why? Why not 5? This is object P1. This is object P because they are different objects. Okay. Then we will see that the print P dot y also 0 because they are different objects. Okay. Now we can create another object. So let's say I have P2, P3. Okay. So I'm making P2, P3, and just make any value. Okay. So P2 is a point, and I'm going to assign x equals to 3, y equals to 5. And then let's make the x of P3 equals to 4 and y equals to 4. Then the collection of your data will be something like this one. When you create the object P, you will have X is 0 and Y is 0. When you create the object P1, the X is 5 and the Y is 2. When you have the object P2, the X is 3 and the Y is 5. When you have the object P3, then the X is 4 and the Y is 4. So using the object, this one is more better in the visualization compared to using the array, one-dimensional array, or the two-dimensional array. Because if you use the one-dimensional array and you use the two-dimensional array, yeah, you need to have a lot of structures to define the data. When we deal with this kind of object, it is the same like variables. It means when you have a value, you can update the value from that particular object. Updating the value means you can do the mathematical operation, you can do some function, and etc. So let's suppose I want to update P3 dot x. It means the value of x on the object P3, I would like to plus with 4. And the value of the object y, the object P3 and the variable y, I want to minus with 2. So the result will be 8 and 2. Now the data will be updated into 8 and 2. When we deal with this kind of class, we can use methods. You can see from this class diagram, we have the class name, this is point. We have the attributes, which is x and y. And now let's have one method. One method here, the method name is translate. So methods, or we know about function in Python. It is the behavior of the objects. We use def to define the method. This is the same with function in Python. And it refers to a function of the respective objects. It means that whenever we have an object, let's say we have P, so we can do something. For example, I want to do translate. What is translate? Okay, we have self dx dy. So self, okay, so I will explain later. And we have dx dy. So this is two parameters. Okay, we have two parameters. You already learned about the functions with parameters. We can have one parameter, we have two parameters, and so on. Now we have a function with two parameters, and we have a parameter sum. The translate method has two parameters, x and y, dx and dy. So self is a parameter that references the object itself. When you use Python, you need to declare self. Python will know that this function is inside a class. Because when we do with this self, it means Python will understand this refer to a particular object. If you use the P, then this is the self for P. If you use the P1, then this is the self for P1. If you use P2, then this self is for P2. As you know, P dot X will have their own value. P1 dot X, it has different value. P2 dot X, it has different value. So you need to declare the self in order to understand where is the object. So what is the value of that particular object? So using self, you can access the object members in the class definition. Whenever you use the self, so you can access the attribute. Now you can see I'm using self in the parameter, and then I have dx, I have dy. Self dot x, it means I want to access the variable x on the particular object. So if I'm using p dot translate, when I call p dot translate, it means I will know what is the value of x on p, because I use self. If I use p1 dot translate, then I will know the value of x with regard to the object p1. So the p1 x, maybe it is 4. If the p is 5, then it is different. Different object will have different value. So in this case, I'm using the self.x, and it will be updated by self.x plus dx. So dx is the value of this one. And self.y plus equal dy. Then it will be updated with the dy. Means if I have a point, let's suppose the point is 2.2. Okay, this is 2.2. And then if I do with the translate, let's say I do the translate 1,2. 1,2 means 1 will be added into x because it is the dx, and 2 it will be added into y. Then it will be shifted into 3 for the x, and it will be shifted into 4 for the y. It means the point, it will be translated to another point after we have this function. So let's see. I'm using the P4. Okay, let's make a client code and create the object. So let P4 be the new object and call the method. In this case, call the method translate with 2 arguments. The parameter includes self, but we do not need to use self to write the arguments. Now let's see. We have P4. Okay, P4 is the point, and then P4.y is 4. And y is 4. P4.y multiplied by 3. Then 4 multiplied by 3. It is 12. P4.x plus equal 1. The value will be 1 because the original value or the initial value is 0. 0 plus 1 will be 1. So print x and print y on the object P4. Because the value is 1 and 12, the result will be 1 and 12. Now let's translate. P4 translate 3 and 2. 3 means I'm going to do the translation from x equals to 1, it will be added with 3. Then it will be translated into a new value, which is 4. And then y. Y, it is 12. It will be translated into a new value. After we do the plus 2, it becomes 14. Then the new value of x in the object P4 is 4, and the y in the object P4 is 14. And when you print those two values, the result will be 4 and 14. Let's see. We have P2, P3. We can do something like the addition, subtraction, multiplication, division, and so on. And we can have a class with methods. So the class point x equal to 0, y equals to 0, and then we have one method, which is translate. So we can have a new value of P4. Okay. Then the new value will be 4 and 14 after we translate this one. There can be multiple behaviors in the class. It means there can be many functions. There can be more than one functions. Now let's suppose we have the translate, which is self dx and dy. We can have another kind of function. I'm using the new function set location, and there are two parameters, new x and new y. It means if the original value is 0 and 0, I'm using this function and I will update the value of x and y. And the value of x will be the new x and the new y. And you will have a new class diagram like this. The variables are x and y. Now we have the method translate, where there are two parameters, dx and dy, and those two are integer. Set location. So this is the name of the method, and we have two parameters, and this parameter is integer and integer. We can call other functions in the class. If you look at the previous Python code, we have translate, and when we use the translate, we do the plus. We do the plus. Now I'm changing the function statement by using the self dot set location. So what is set location? This is a function. Here is the function. So I'm using the set location to update the x. How can I update the x? The x will be self dot x plus dx, and the y will be self dot y plus dy. This value will be a new y, and this value will be a new x. So we can update x and y based on the new value. So using this one, you still have the same class diagram, but the statement are different. Okay? So this statement is different with the previous one. Now let's make the client object. Make the client code, and let's create a new object and call the function So I'm calling the set location and I'm calling the translate. Let's P5 is a point and then P5 equals to X. P5 dot X is 3. P5 dot Y is plus 2. Then the P5 dot X will be 3 and P5 dot Y will be 2. We do the set location. So set location means we just update the X with 8 and 8. Then X will be 8 and Y will be 8. We want to do the translation from the X and Y. Then previously it is 8, it is 8. 8 will be plus with 1, then it will be 9. And Y will be added by 2, then it will be 10. So you can see the result like this. Then we have the translate location. Yeah, you can update the translate by calling a function inside the class. And I'm creating the object P5, which is X and Y. And when we update it with the set location and translate, so we get a new value like what we did. Okay, let's have a break. Then I will continue after the break.